It is the LaSalle Education Complete Maths Autograph Webinar course, part of a 4-part series. Last week we did the Shape course, which is available on the LaSalle Ed YouTube channel, where you can watch and listen and hopefully work your way through the tasks that we've completed. All the resources are available on the LaSalle Education Complete Maths website. www.completemaths.com. This week we're looking at session 2. We're going to look at some line tests, graphs of the form x equals a and y equals b. We're going to look at using the constant controller for y equals mx plus c, some solving equations, completing the square, inverse functions, trigonometric graphs, and so much more. Hopefully you'll find the session useful. We've emailed out some how-to guides and some tasks, which hopefully you've got, but we'll try and drop them into the chat as and when we use them. This week, your co-hosts, again, are myself, Robert Smith, and Douglas Butler. You can follow Autograph Maths on Twitter with @AutographMaths and LaSalle Education @LaSalleEd. Doug and I look forward to your feedback and comments, as well as any screenshots or little video clips that you might want to share from the creations of an autograph. Doug, if you'd like to kick us off with our first task, it'd be much appreciated, and I'll take to answering questions and comments in the chat.
Well, good morning, everybody. And for those of you who were not here last week, this is certainly a new experience for you. I've had one go at this so far already, and it's been good fun. When you first launch Autograph, you get this welcome page, which possibly does suggest that it really is only useful for teaching A-level. Maybe we should put some extra scenes in here. But anyway, there are lots of opportunities for using Autograph in the ages 11 to 16. So that's what we're concentrating on today. And let's start away. I'm just going to open up a file left over from last week. We didn't quite get round to it, and it's quite a nice one on triangles and tests for parallels and so on. So what I've got here, I've just got a couple of line segments, and if you double click on each one, you see that I've locked these 3 points, so I can move this one around, and the challenge is to move it around until you find that one line segment is perpendicular to the other. You could just sort of guess, but it'd be much better if you actually worked it out. There we are. That is 3 along and 1 down, so 1 along and 3 up will be perpendicular. Also, by the way, they're equal. So you might think this is very useful, but as a teaching tool, maybe 2 screens next to each other would be quite good. One with the original and one with a blank screen, so you can see how it all works. I'll do that in a second. Just to show the other thing we wanted to look at was triangles and properties thereof. So I'm going to open up a new page, and whichever page you have highlighted will, when you do Window, Windows, and we're going to press the Control key to select 2 windows. I want page 6 and I want the triangle one, and we want to tile vertically. And you can see that the empty page is the one that I have highlighted. So I can move this across and move this one across. Notice that if I hold down the mouse and just let it go, it becomes the drag. Or if you're not sure about that, just press the drag and move it over like that. We've also got the key down here, which is for plotting for listing equations, but I'm just going to take that away because we don't need it now. Okay. One thing that is new in Autograph 5 is the extension to the point mode. So this is putting points on, and you'll notice we're in this standard level. And if you're not sure about that, it should say 1 and 0.1 here. If it says pi for radians, then you're in the wrong mode, because we do want to have everybody on the same one. So if you do View, Preferences, and just switch across from Advanced to Standard, then they're all the same. Standard has no calculus, has no radians, it's just a simpler interface. And also putting points on only goes to integer values. But you can always put 0.1 if you want to be in more detail. That is the select mode, which you should always return to in order to do anything useful. So drag select is a way of selecting points. and right click, delete. So if I extend this, you'll see that you can not only put points on, you can put intersection points, which we'll use quite a bit today, and you can use line segments or vectors or circles. Line segments is what we want, and we want to put a line segment down here. I'm on point 1, I meant to do 1, so select again just so that it locks into integer values, that's what I wanted, and do another line segment, say like that. Now at the moment they're clearly not parallel or perpendicular or anything or equal. They're equal in fact, but the test to do it is to select the two line segments and right click. It's a line operation. Again, if you're new to AutoCAD 5, you'll be surprised to see these sub-menus here, but it's just a very neat way of getting a lot more options. So you want the parallel test, and you also want the equality test. And you can see that as you move this around, it becomes parallel and equal, and sorry, that's parallel down there. So it's quite a nice little exercise to have a look at this. If you want to know how to lock a point, double click and just do lock one or both coordinates. If you've got an exercise that you don't want people to mess it up, then that's quite a good one to do. So I think we'll probably pause at this time and give you a chance to, you may want to practice this idea of having two screens open, but certainly the idea of using the segment mode, that's this one here, to create segments at different places. And then explore. Remember, to do the tests, you need to select the two segments, right click, line, parallel test or equality test, depending on which you want, or both. Okay, we'll have a little pause now. I'll give you a chance to practice that.
Hopefully you received an email with the documents that we're going to use with the how-to guides and the tasks. I've shared the lines test document into the chat. So if you haven't got that to hand, you can pick it up from there. Doug, I think some people were asking how to do the split window mode. So if you just want to quickly show them the window menu at the top.
Yep, certainly. If page 6, let's just have a new page. Supposing this is the page, and you want 6 and 7, and you want 7 to be on the left, and you want the triangle to be on the right. Go to the Windows menu, and right down the bottom it says Windows. And as long as the one you want on the left is highlighted, then you select that, and you have to press Control, just as you do in any other environment, to do a selection which are not next to each other. And then vertically or horizontally. Vertically is the sensible one to do, and then click OK. And there it is. There's 7 on the left and this on the right.
Jill's asking, how do you do the test after selecting both lines, Doug? It's with a right click, Jill, and you select both lines using select mode. Select mode, click both lines, right click, line, and parallel test and the equality test. You can lock the point by double clicking on the point. It'll launch the enter coordinates box and you can just tick the lock option. I think the how-to guide locks 3 of the points and you can move the other point around. It might be useful to show how to hide the axes there as well, Doug, for those that might want to hide the axes.
It's just a single click up here.
Yeah.
And to get rid of this, right click, don't show the key. If you regret that decision and there's no option to put it back again, it's in the Axes menu show key. And remember, we are in equal aspect mode, which is very important because if you're testing whether something's perpendicular to something else, it'll look very strange if you're not in equal aspect mode, because you'll find something that appears to be not at 90 degrees, but actually is marked as such. The zooms are a good way to mess that up. You know, if you want to zoom that triangle and make it a different shape altogether, you can see what you've got here. That is not a right, well, it is a right angle mathematically, but visually it's not. So equal aspect will sort out the X scales so that it is indeed correct.
And then you can use grab mode to recenter that to the center of the screen.
Indeed.
Perfect. So hopefully you're able to follow along with that. If we give you another minute, and then Doug will show us the equality test using the triangle and calculating the area. Doug, quick question. Someone's asking if they can close the welcome page. If you click the welcome page, on the far right-hand side, there should be a little X that you can click to close that.
I'm not sure that that works. You might have to consult Mark on that one. It's a very nice page, and it's just sort of likes being there. Doesn't get in the way once you've started something else. It's just in the background.
Hopefully that answers your question, Mark.
One thing I didn't mention was how to display the labels associated with the point, and also to change the shape of the point. So if you've got this point selected, right-click, Edit, Draw Options. Very, very useful. This for any object, you can change its appearance. In particular with points, if you want this point to look different to the others, which are locked, it's just down here. It starts off as a circle, but I've chosen diamond. And normally it's 7, but if you bump it up to 11 or 12, you get a nice big one, which looks very different. Also, with that selected, right-click, you can edit its label. Or if the label is not there at all, like this one, for example, you can show the label. Now, the label will just be a capital letter, but on its own, but you can edit the label. So right-click, edit the label, and you have these choices here. You can call it what you like. You can show its value, and you can, there it is, so it's all sorted out. All the ticks in the right place. Move this around a bit, but it is attached to that point, because if the point moves, the label moves with it.
Doug, one last question. Someone's asking where the parallel test is again. So if you just select both lines.
Select both lines,
right-click, line, parallel test.
It's got double arrows because we've done it before.
Okay, Doug, shall we move on to looking at the triangle?
Yes. Now what we've got here is I think something, the fact that the area of a triangle is half the base times the height is something you can prove very simply with lots of triangles, and even when it goes negative, you're subtracting areas. But it is nice, I think, to show it dynamically. So what I've done here, I've put a point here, and I put a horizontal line through that point. So that line is fixed. And this is the point I'm moving along. I've also created the midpoints, and I've checked that they're parallel, and I've done the closest point from the vertex down to the base. So let's go over here and show you how all that's done. So right click, don't show the key. Aha. I'm still, you see that's white and that's brown. That's the one that's actually occupied. So if I do right click, show key, now click here to get my attention on this page, and then right click, don't show key. Okay, I'm just going to drag this across here. I'm going to put a point here because I want a horizontal line through that. So a point and right click, line, horizontal line. Then back into point mode, I'm going to put a point here and put a point on the line somewhere, doesn't matter where, and a point down here. That's 3 points. I'm selecting them all. Now, when you do a marquee select like this, it only selects points, does not select anything else like lines. So I've got 3 points there, and I'm going to group those into a shape. And that shape, you can move these around. You can move these around too if you wish. So this is a series of points. So if I select 2 of the points, and this is how autograph works. You select and then right click, point, midpoint. Deselect, always deselect before you start a new selection. Select, select, right click, point, midpoint. Now I need to go to the segment mode because I want to draw a segment from, wait for the little white triangle to, you see, it doesn't know where it's going to end up, but if you end up here with the right triangle right in the middle of it, it's quite happy. And we want a line segment along here. And now select the 2 line segments and right click, select the 2 line segments. I must have had something else select. Ah, there's a point selected there as well. Oh well, that's got it. It was selecting the shape at the same time. So right click, line, parallel test. Then to do the perpendicular from here to here, select the point, select the line at the bottom, the base, and right click. It's a point thing to show the closest point. Now it's a little bit thin, so I've selected that, and in fact you don't need to go to edit draw options because it's up here. Just make it a bit thicker. It's better. Now how about measuring the area? It's a pretty simple diagram this, so half the base times the height, you can do it in your head. But it's good to show that autograph is on your side here and can give you a hand. Let me introduce to those who weren't here last week, the calculator. Very, very useful. Because every object in autograph excuse me, has attributes. This triangle has a perimeter and it has an area. So if I hover over it, you can see that it's offering the calculator the perimeter or the area. So if I do area, it calls itself B because that's the label on this thing if we were showing labels. And just put area equals with a couple of spaces. Click OK. And that becomes a live box. Hang on, I've got everything else selected there. That's not good. Right. So it stays at 6, whatever we do to this. So see if you'd like to have a go at that. Remember, it started off as just 3 points.
Can you show how you did the perpendicular to show the height, Doug? Someone's asking in the comments.
Certainly can, yes. I'll just do it on this new triangle so you can see where it works. So there's the line segment there. And we want this point and this line segment, and right-click, point, closest point. And that will drop a perpendicular as required.
Dan, hopefully that answers your question of how to get the closest point for the line segment for the height of the triangle.
Always remember, deselect by clicking nowhere before you start a new selection.
And Doug, if you want to plot the midpoints on your new triangle, so you select both points that you want the midpoint for.
Yep.
So
first, select,
right-click,
point,
midpoint. Hopefully that answers your question on how to get one midpoint. If you create the midpoint the other side, point, right-click, point, and midpoint. The instructions are in the how-to guide, so you can refer to the document. Hopefully that will explain how to create the triangle that Doug's demonstrated, or one similar.
Always remember to go back to select.
HZ wants to know how you lock points, Doug. So if you just go to select mode and double click the point, it will launch the edit coordinates box, and then you have the option in the checkbox to lock those coordinate points. Again, it's in the how-to guide. Hopefully that's useful. If you've got any other questions, feel free. How to plot the line from Josie. So if you just put a point on the page, Josie, so you can put a point there on the grid. And then you right click, and in line mode, you can create horizontal and vertical mode lines, and creating the line segment that represents the height of the triangle. You click the point and go to the line and right click, and in the point, it's the closest point option in the point. Closest point from the point menu. Remember, if you want to calculate the area of your triangle, you just click the calculator, select the triangle. You have the option there to get the perimeter or the area. We're going to choose the area. We can put the before text. We can type area equals.
Particularly instructive, I think, if you pull it over this way. And of course, there you're talking about subtracting that area minus this area. Same result, of course.
Matt Hine is asking, can you attach labels so they move when the shape moves? Yes, Matt. You can attach them to the point, like the coordinate point there. It's got the label attached to it. But you can also have the labels not attached to the point. But Doug might show you how you can attach to the point.
Select a point, edit label. If we don't want to call it F, but we'd like to know what its value is, we can do that and need to show it. There's space for some more text here if you want to. And that will now change. You can pull it out if it's in the way.
And Jen's asking how you lock the top point of the triangle to the horizontal line, Doug.
Yeah, once the line is in place, you see, wait for the little black arrow. Now remember, it's locking onto whole number values because we're in the standard level and we're on that. And then if you go back to select, you can move it along.
And just one more time on calculating the area again, Doug. So click the calculator. The calculator will launch the calculation box. You click on the object that you want to calculate something for. So for example, the shape, you want the area or the perimeter, you click the shape. That will show you the options available. We've got perimeter and area. And then we can fill in the before text or the after text. If you want to calculate the height of that perpendicular line, you should be able to calculate the length of the line, Doug.
Yes, indeed. It's an object like everything else. So open the calculator and click on it. And it's giving you the distance. That's the one, which is 3.
Hopefully that answers your question, Matt. And then you can move that text box to where it needs to be. Okay, so Doug, if you want to launch the keyboard from the top menu, if you click View and then Keyboard, that will launch the autograph keyboard. So then when we're in the text mode, you can then edit the superscript for the 2 for your centimeter squared. So double click on your height label, Doug.
I didn't catch that.
Double click the height label.
Oh, yeah.
In the after text, you want to put centimeters squared. So we're going to
not for height, but I'll just pretend that it's area. Okay, centimeters and then squared. It's silly, but no.
Yeah.
I notice we've got subscripts as well here, which have their place, and that's raised to the power of n. This is really useful if you're using, as I am. I've got a mouse pad here. But I think it's very important that if you're doing something and it involves a bit of keyboard work and your students can't be sure what on earth you're doing, whereas this way you can see exactly what you're doing. So if you want to delete something, press delete and there it is. Or if you want arrow keys, just moving a point around with the arrow keys is very important. And if you press control, it does it in tenths. If you shift control, it does it in hundredths.
And Karen's just asking, how do you get the area option? Doug, I don't know whether her 3 points have been grouped to a shape, so can you just show how to group to a shape from last week?
Oh, okay, yeah. Just put 3 points down, 1 on there, and 1 down here. Select them all as a marquee select. Remember, that only select points, and right-click, group to a shape.
Hopefully that answers your question, Karen. You can then calculate the area just by clicking calculator, click the triangle, and show the area. Doug, I think it's about time we moved on to look at our x equals and our y equals graphs and look on to y equals mx plus c.
I think so. What we've got here is a nice visual look at the classic straight line, y equals mx plus c, and trying to explore what the m and the c stand for. And to sort of get ready for that, just to be sure they're understanding their sense of coordinates. I'm going to put a blank page on like we did before. And have those two selected. So, for example, to get this line here, this is it's an x equals. A lot of students have trouble with this because it appears to be something to do with y, but in fact, y is the same all the way along it, so it's an x value. If you enter an equation, and it's right-click, enter equation, and if you do x equals a, what you get, you can edit the constants at this point, but all the constants in autograph start off at 1. So if a is 1, then it's going to draw along here. Now that was a bit sudden. I would much rather introduce everybody to the slow plot. And the slow plot is fantastic. I'm not sure we want it quite as fast as that. But this is a replot, and off you go. So you can see you've got plenty of time to sort of pause and think, well, where's it going to go next? In this particular case, it's fairly straightforward. That was x equals a, and if you do y equals b, again, that's going to be this way. Now, again, it's not terribly obvious why it should be that way around, but if you think about it, for all values of x, y is b. So then you might set some targets and say, right, let's go down here. What's a and b going to be to bring those two lines to go through that point? So that's the first little exercise to look at. And then to have a look at our old friend y equals mx plus c. Now m and c will both be 1 to start with. So where's it going to go? Have a bit of a think. Well, it did actually go through there. Now, the first time we've used the constant controller in this session. Constant controller is one of autograph's masterpieces, I think, because you can not only change the value, but you can also change the step. Now, that was changing a, because you've got a, b, c, and m. Those are the 4. If we want to take a down to here, for example, there it goes. And if we want to take b, that's the way of changing a and b so that it goes through that target. Now, what about what's going on with this function here? So let's have a look at the intersection mode. This is a good way of finding out where a particular function hits an axis. You can do it down there as well. As soon as you get the little circle, you can create a point. Now that's a point. What I'd like to do now is do a unit gradient. Now what that does, it goes 1 to the right, and then so far up to when it hits the function again. Now what I'm going to do now is increase the gradient m and see that that's what happens. Aha. Now the really nice thing about this constant controller is that, you know, if you had a slider bar, which all the other programs have got slider bars, things sort of whiz around too quickly, you don't know what's going on. So it's really good, I think, to be able to go down so far and then reduce the step. Now left and right reduces the step by a factor of 10. So now it's going to go much better. Now something quite significant happens now, and then what happens? Well, your x is still 1, you're changing x, but this is now negative. So this is what we call a negative slope. What about c? What does that do? Well, clearly, when x is 0, y is equal to c. So when x is 0, y is equal to c. So c is 1 at the moment, but if we make c bigger, and the nice thing about having this triangle here, you can increase c and it all moves up 1. But without this, of course, you could just as easily describe it as moving to the left. So I think it's quite important that that distinction is made. So that's covered most things, but quite a nice task, I think, is to put a couple of points on And let's do this. That's here. Let's go back to point mode. Put the point here and a point here. So, and then let's find the straight line that goes through those points. First thing you want to do, of course, is work out its gradient, and then play around with m and c until it goes through that point. That I leave you as a little exercise. Have a go at this. Still there, Rob?
Yep, still there. We're going to have a look at the tasks and the y equals and the x equals. To get the gradient triangle, Doug, can you just show how you got the gradient triangle again?
Yes, any point on a function, doesn't matter where it is, you can ask for a line option of the unit gradient. So that simply marches one to the right and then however far up. One to the right and then however far up. As you change things, let's increase the gradient. You can see that it does that. The step now is 0.1, which is why it's going in small bits. When it goes negative, obviously with a straight line, it's going to be a lot more interesting when you've got this happening on a curve.
And the constant controller you can get from the toolbar. It's the K with the two arrows left and right, or you can click View Constant Controller. Again, all the instructions in the how-to guides with the tasks and questions that you can use as well. Oh, Doug, if you can click the calculator and in the box, if you can just put M and then in the before text, M equals. And then if you click the calculator and put C and C equals or Y-intercept equals, that's one way that you can display the values of M and C.
So what have we got here? The gradient is 2 along and 1 down. Okay, so the change in y over the change in x minus a half. So put that in. So we change m to minus 0.5. And just check that that is parallel to that. So what we've got to do now is change c, reduce the step, come down a bit. Bingo.
And a quick question there, Doug. Is it possible to display the height of the gradient triangle? Can we...
Can't remember. So look. Ah, I thought it was, but obviously not. There's another thing to look at, which is the text box. It sometimes carries information, but no, it only gives the gradient.
You could construct your own gradient triangle and calculate it,
Yes.
Rob, so hopefully that answers your question. We'll give you some time to have a go at the tasks in the document. Doug, do you want to show the tasks in the file? For number 2, graphs and y equals mx plus c. You don't need to select the line to get the constant controller to display. You just deselect by clicking anywhere, go in View, Constant Controller. And a question about locking the text box so they move when you change the line. Is that possible, Doug?
I was just thinking about the constant here. Because this gradient, because that's 1, then the value of the gradient is automatically the distance, the height here. So it's the same thing. That is the minus 0.5.
Have you got the task document, Doug?
Yes. And it's number
2, x equals. And you'll see that all the instructions of how to do this task are in there. And if you get to the end, you'll find some graphs that you can construct yourself using variables. And Rajan's asking how you animated the line being drawn using slow plot, Doug. So if you want to just quickly show how to turn slow plot on by clicking the green icon in the toolbar.
Yep, you can either put it on here, what I was doing, or you can put it on here. It's off now and it's on. And if you want to go back to the equation entry box, double click on this. You're back here again and just press OK. But this time it's going to go slowly. So you could pause it now and ask, is it going to come from up here or down here? I'm hoping it's going to end up going through those points. Slow plot speed is up here, a little pull to the right or left.
And thanks, Nick. Yes, it's documents 2A and 2B that we're looking at the moment. So if you've got any questions about the task in those, drop them into the chat. And hopefully the instructions are there that you can follow along with all the options of how to turn on the constant controller and which menu to click to enter the equations and the like. And thanks, Mark, for sharing the Dropbox links to the files for this week. So
Are you ready to push on?
We just got a couple of quick questions. Doug, how do you label the Y-intercept? So we're going to go to the intercept point.
Here's the intercept mode. Wait for the little circle. And there it is. And it depends what you want to say to it. So let's right-click, edit the label. And you can call it what you like, intersection.
And then the follow-up question to that, Mark is asking, how do you display the results box to the right-hand side? We can do that from the axes.
It's in the view. All the things you want to show are in here, and results box. What the results box is simply a collection of text files of things, objects that we've created and their results. It's just there for you to do whatever you like to. It's text, you can select, right-click, copy, put it into a Word file.
And we also want the key to the right-hand side, Doug.
Oh, I very rarely use that, but you certainly can. This is the key at the bottom, and this is the key at the right-hand side.
And you can extend the key to display multiple lines as well, Doug, for when we've got more lines as well. So
that's true, yes. It can go all the way down the page there.
Yeah. Can you make the key narrower, Doug? Can you extend your screen back out and have the key box smaller?
No, it's the way it's set up. It's a square arrangement.
If you go back to a normal view there and do it from axes and view rather than from there.
Oh yes, you can have more down here. That's what I mean.
No, if you go to axes, option.
Yep. I haven't told people that if you double click on any axis, you open up the Edit Axes menu. And one of the options is to say how many entrants you want in the key. So if we bung this up to 6, it'll plenty of room.
Yeah. But if you go axes, Doug.
Yep.
Edit axes. Options. Key right. And up it to 5 entries or 6 entries and click OK. That doesn't put it into square mode, so you can have it a narrower key that way.
Well, there we go.
Hopefully that answers your question, Mark.
How long have I been playing with autograph? And I didn't know that.
We learn something new in autograph every day, Doug.
Certainly do.
Should we go on to look at solving equations, Doug? Because there's quite a few tasks in document number 3, and I think it'll be useful for people to have a bit of time to be able to play with solving equations. There's some nice questions in there.
So it's the simultaneous linear equations we're looking at now, isn't it?
That's correct.
Yes. Now, the form for the straight line y equals mx plus c is just one way of introducing people to straight lines. There's another form which is a little unusual because it's not x equals or y equals, it's a bit of both. So let's do enter equation now. And let's do 2x minus 3y equals 6. So it's an unusual format. As it's not y equals, it's not x equals, so it's both. So click OK. We've got the slow plot on, so plenty of time to think about it. And now you stop. Now the stop is really, really useful. So when x is 0, what have we got y? Y is going to be, and this is where the pen is quite useful. So I'd like to introduce you to the pen. Now it depends what you've got with you. If you've got a mouse, that's really helpful because you can click on this and you can draw little circles with care. If you've got a pen like I have, you can be even more careful, and that's not wrong. So what have we got here? When x is 0, y is -2, so it's down here. So it's definitely going to go through that point. When y is 0, x is 3, so it's going to go through here. Right, so we're expecting it to appear from down there and to go through up like that. That's the sort of chat you want to have before you plot anything. That's the autograph way. In it goes. Boom. And of course, if you got that wrong, there's plenty of learning there to be had as to why it was wrong and so on. Edit, select all scribbles, and delete. So now we put on a second equation. Let's do x minus y equals 3, something like that. That may not intersect, but that's, we'll see. Let's do fast forward. Very boring, so let's change it to something a little less boring. Let's put a 3 in there. That wasn't very clever, was it?
So let's look at solving the intersection, even though we can see where it is, Doug, and then we can look at some of the examples in the tasks that actually have the questions that they can have a go at themselves and solve using the intersection. So
here we have, there's two ways to look at this. One way is to just literally zoom away and just zoom, 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 zoom. And what are we ending up with here? It looks like that's 8, but this is going to be some fractional value. If you get in a muddle and zoom and you literally lose everything, just press the red tick and it all comes back. You might want to do equal aspect as well. Now, getting the computer to give you the answer, because obviously you do it by algebra, but it's good, I think, that the computer can do this for you. And just wait for the little circle, and then right-click, you can edit the label, and you can show the answer by showing it.
I think the how-to guide also does it by collecting both lines and solving the intersection, Doug.
Let's have a look. If you select both the lines, and these needn't be straight lines, it could be curves or anything else, but you can right-click, point, solve, intersection. And what if you select that, and then the text box, it tells you in a nice sort of format, intersection equals.
Now, you might want to change the anchor as well, Doug, for the point, to show how that works.
Yep. If you double click on the, this is the text box, and you don't want it to anchor to the point, you can then park the text box somewhere over here. You may want to do that.
Or you can edit the minimum distance that it's away, so it's can be dragged further away, but still close to the point.
So double click and anchor, but minimum, make that 30. And there's still a maximum.
So, Doug, do you want to display the tasks? And there's, I think, about 10 questions that people can have a go at. There's lots of different equations that people might want to use the keyboard and use the fraction element on.
This is number 3.
Hopefully the step-by-step instructions are there that will allow you to solve these, but you can hopefully have a go at some of those to build your confidence with using solve intersection. Doug, why don't you have a go at demonstrating number 1 there? 2x plus y is 18 and x minus 2y is minus 1.
So 2x plus y equals 18.
So enter equation, 2x plus y equals 18.
Okay, and slow plot. We'll take the slow plot off now because it's been a bit slow. And then the other one is x minus 2y equals minus 1.
So again, enter equation, x minus 2y is minus 1. And if you use the grab mode, you can use the grab to bring that to the center. And you can use the point mode and find the intersection. The little circle will appear when the intersection's there. And then you can display the text box or edit the label to display the intersection. So the solution would be 7 for x and 4 for y. Hopefully you managed to create that one, and there's some others there for you to have a go at. We just want to build your confidence using autograph for solving equations. We'll spend 3 or 4 minutes just having a go at some of those tasks, and hopefully you can have a go at those. Any questions, drop them into the chat. If you want to know how to display the label or any of the other options, feel free to drop it in the chat and we'll give it a go. Mrs. Wall's asking why the intersection is a square instead of a circle. When you get to where the intersection is, it turns to a circle. And then when you use the select mode, if you select the point, right click and edit the label, you'll see there that you've got the show label and anchor to point. And then that would be why the anchor to point option would be grayed out, as if it's a text box that's not attached to a point. Ben, if you wanted to display a mixed number in the equation, if Doug has his keyboard on, he can do equation, enter equation, and then he should be able to use the keyboard to do his 5.5 fraction by clicking 5 and then the half symbol. Ben, you've also got the third option there. I think entering it as an improper fraction is probably a nice way to do that at the moment. If you need a workaround as to how to enter a mixed number fraction, or you can do it looks like we're about an hour into our session, Doug, so maybe it's time to have a look at the next section. Hopefully, if there are any questions, you can drop those questions into the chat. I know there are some tasks attached to the next section, Doug, so we want to maybe click to those.
Okay, what I thought I'd do is push the next two on, because there's some other things I want to cover, if possible, before the 12 o'clock deadline. The next thing is obviously straight lines we've had, and things that curve. The first ones they come across are the quadratic curves. And the king of all of those, of course, is y equals x squared. And just do xx to give you an x squared. And if slope plot is still on, then you could discuss where it's going to come and so on. So how that gets transformed by various other numbers attached to the equation is very important. So if you do y equals axx, where a is a number, a will be 1 to start with, so it's just going to plot straight on top of the other one. But looking to see what happens to a as you change it, let's have a look at the constant controller now. And I'm going to press this button here, which will make a 2 instead of 1. What's going to happen to the graph? Don't just do it and say, oh, look. See if you can puzzle it out. Obviously, when x is 1, x squared is 1. So if a is going to be 2, 2x squared is going to go up to there. Let's have a look and see. Ready, steady, go. Yes. And then you can go all the way down the bottom. But again, with a slider bar, things tend to happen far too quickly. So what I'd quite like to do is get down so far and then reduce the step and go down a bit further, a bit slowly. This is a good time to introduce you to the animation possibilities of the constant. So if we have a look at the options here, you can do a family plot of graphs with particular values, or you can do an animation up and down. So let's do animation up and down. Let's go from -3 to +3 in steps of 0.1. That's pretty good. Click OK, and then watch it do it. So they should get a really good feeling of this, that when you have a quadratic expression, and if the sign of x squared is positive, then it's this way up. If it's negative, it's that way up. Okay, so we'll go back to manual and make it 1 again. So what I want to do now is have a look at what happens if you do enter equation y equals brackets x minus, let's do b now, but we'll still want it squared. Squared is here. Now, I'd like b to be 0 to start with, so that you can get that in, and that means it's going to start off exactly where the other one was. So there's no change. But now if we change b, which way is it going to go? Now, if you look at this, when x equals b, that's when y is equal to 0. Therefore, the value of b tells you where the vertex is going to be. So if b becomes 1, the whole thing is going to shift to the right to here. So that's going to be the origin, the vertex. Let's have a look and see if that is indeed the case. Yes. Again, try to anticipate all this sort of thing before you press OK. Then as a general rule, to have a look at this, let's have a look at one that I've got here. Now, once you've understood what minus a and b actually mean, this is quite a good way of having a look at rearranging this equation as a perfect square. And if you do so, I'm suggesting that x squared minus 3x minus 1, which is the red one, can be reformed as x minus a all squared plus b. Well, I'm going to start off with a equals 0 and b equals 0, and so it's just like that. So what do I have to do to open up the constant controller and just make sure that this graph ends up on top of this one? So what is the translation that's going to make this happen? So first of all, I'm going to change b, but what I quite like to do is have a look at here. The intersect mode shows all sorts of things. It shows you where that intersects the x-axis. It also shows you where the minimum is. So in that, I'm going to draw a vertical line. I'm going to select the line and edit draw options and make it dotted. That's better. Okay, can I get this orange one to sit on top of the red one? Let's have a look. First of all, I'm going to change A. No, I'm not. I'm going to change B because I want to move it to the right. I mean A, forgive me. All right. I'm going to move it to the right until such time as it is symmetrically placed over the other one. Now I'm going to change B, which is going to move it down. Now, is it going to? No, it doesn't quite meet it. This is where, again, a slider bar would totally fail. I want to reduce the step to 0.01. And there it goes. And if I'm not sure, I can always get the zoom and take a look. Yeah, that's absolutely bang on. Red tick will get us back to sanity. And finally, I'm going to put a point at the origin, enter coordinates 0, 0. And I'm going to create a vector on there of AB to really hammer home the idea that this is a translation. Vector A and B should take this point straight down to there. So that's a visualization of what goes on in a very algebraic process of changing this into this. So I think it's probably enough for you to have a little play with.
The bottom of the document 4B, Doug, has the task. So if you want to scroll down to the bottom there, you can see we've got some examples there for you to have a go. Hopefully you can drop your questions into the chat. And we'll do our best to assist you using this for completing the square. I'll just drop that document again into the chat for those that haven't got access to it. Hopefully you're able to follow along at home, but if you've got any questions or comments, drop them into the chat, and hopefully you're having a good go at the example that Doug's provided there and following through the instructions in the how-to guide. You'll see that there are 4 parts to task 1, and hopefully you're able to use the constant controller to adjust the step accordingly to find the transformation. And Doug, Katie is saying that she's put a point at the turning point and made a vertical line, but the line doesn't move when she changes the constant. I would think that means that the point isn't connected to the intersection there, Katie. So if Doug, you want to just demonstrate to Katie how she might do that.
Okay, I'm just deleting the vector. Getting all that out of the way. Okay, here is the virgin graph, although let's just move it away somewhere else. Now, one of the options in the intersect mode here, it not only finds intersections with the axes or with other graphs, it also finds its max and min points. So that is definitely a point that you can't move because it owes its life to that graph. It won't move anywhere. So there you can select that and right click, put a line vertically to that, deselect, select the line, right click, edit draw options, make it dotted or whatever, because it's a construction line.
Hopefully that answers your question, Katie. But yeah, you look like you're doing really well. So keep dropping those questions and comments into the chat. Anne saying that when she enters her equation, it doesn't appear. May I ask which equation you're entering, Anne, just so we can see what happens? It might be that we need to zoom out in order to see it with the axes that we've got. X squared minus 2x plus 16, Doug.
Well, 16 is off the top, isn't it? So that's almost certainly it. Let's try. Is that it? Something like that?
So we should be able to use grab mode and we can slide.
Or zoom out. And then grab. It's certainly there.
Hopefully that answers your question, Anne. You can use the zoom in and out on the left-hand toolbar. And Jill's asking how you draw the vertical line from the point again. So if you create the point, right-click, and in the line mode, you've got a vertical line there, Jill. So you should be able to hopefully manage to create that vertical line. And Phil's saying that he's got the point at the minimum. So when the point is at the minimum, Phil, if you just click the point and right click, then you should be able to right click and create a vertical line. If you created the turning point, you might need to go and add an additional point on top of the turning point by clicking when the circle appears, right clicking, choosing line and vertical line there. hopefully that answers your questions, Phil and Erica. But if you need further help, drop a comment into the chat, and we'll do our best to help you before we're going to have to move on, I think, Doug.
Yep. We've got to decide what we're going to do in the last quarter of an hour.
Well, I would stick with number 5, y equals x to the n.
Yeah, that's a good one. So a new page. Once they've been introduced to the quadratic function, of course, the next one is cubics and reciprocals and so on. So it's just an exponential function as well. Quite a tricky set of ideas to get across. So let's enter an equation. I like to put in y equals x squared because it's the sort of king of everything, really. And then if you do y equals x cubed. But before you do so, I think it's time to get the pen out. I find this with some quite senior students. You know, they haven't been visualizing their mathematics as much as they could. So if I ask them to draw y equals x cubed on the same graph as y equals x squared, you get all sorts of results from even quite talented mathematicians because they haven't really thought it through. So you say, right, x squared is x times x cubed is x times x squared. So it's going to be x times whatever it was when it was squared. So for example, when x is 1, obviously 1 cubed is that. When x is 0, it's there. And when x is minus 1, it's there. When x is a half, it's going to be a half of what it was when it was cubed. So it's there. It's going to be 3/4 of what it was when it was squared. And it goes. And of course, it gets sandwiched into the constant, to the 0 here. Then the same thing happens on the way out down here. Have that sort of discussion before you then enter equation y equals x and see how you got on. I should have had the slow plot on, forgive me. Let's replot. Then edit, select all scribbles and delete. What is quite useful now is to convert this into not y equals x to the power 3, but y equals x to the power of n. Now n, of course, is another constant, and it'll start off with a value of 1. So if I press OK, what's going to happen? It's going to be the line y equals x at 45 degrees. Should we have a look at that? Take the slow plot off now. But now the constant controller kicks in. Constant controller. And in steps of 1, I'm going to make n 2. Well, we know about that. 3, we've just been exploring. What about 4? What about 5? What about 6? What about 100? What's it going to do when is it going to be a right angle at that corner? Well, let's go and have a look. Zoom. No, certainly isn't. It's got to get up to 1, 1, but it just takes a long time to get on with it. Red tick sorts out the scales. Equal aspect just in case. So let's go back let's reduce the step. So increase the step to 10 rather and bring this down to 90, 80, 70, 60, 50, 40, 30, 20, 10. Reduce the step. 9, 8, 7, 6, 5, 4, 3, 2, 1. What's going to happen next? Really good thing. Now, if they've all got their own little drawing pads or whatever, see if they can predict what's going to happen. What we're talking about here is a mode of using the technology that I've been really keen on all my life, really. A big screen in front of the kids, and they've got some way of recording what their thoughts are, and they can share it with you. Obviously, a fully electronic system is great as well, but that's pie in the sky for most people. So if n is 0, of course, it's going to be that. Then what happens when n is minus 1? Try to do a table of values, and this may be the first time they come across infinity, who knows? But there's so much to talk about before they get that shape, and that is in the curriculum for the secondary course. I don't think they have to go much further, but there's no reason why they shouldn't start doing it. I mean, the inverse square, very important rule, television signals and all sorts of things. So having a look at those is important. I think we're going to have to push on because I want to show you the y equals 2 to the x. Now 2 to the power of x is a very important function. It's the doubling thing. Those who've been watching the quiz program last night will understand that doubling is a pretty important feature of mathematics. And when it comes to money, from 500 to 1,000, 1,000 to 2,000 and so on, it starts to get serious. And that's the same happening here. So make sure the slow plot is on, because there's lots to talk about here before it actually gets anywhere. And this is where the pen comes in again. So when x is 0, what's 2 to the power 0? Anything to the power 0 is 1. 2 to the power 1 is 2. 2 to the power minus 1 is going to be a half. 2 to the power minus 2 is a quarter. Yes, on we go. Now, if we zoom out of this, you'll begin to see what an amazing function 2 to the power of x is. It just goes to the moon. And you know, if you're talking about who wants to be a millionaire, then that's what's happening up here. The questions get pretty interesting. Red tick. Notice also that everything I've done is stored away in previous pages along here. Very useful to be able to look back at what you've been doing. So what we're doing in this session was having a look at y equals x squared, and then y equals x cubed, y equals x to the fourth, and so on. That's minus 7, minus 6, minus 4, 0. That's a very important one. 1, 2, 3, 4. So it's just entered very simply as y equals x to the power of n in relation to y equals x squared. And then we had a look at 2 to the x. So have a little quick play on that, but we are running short of time, but just so you get a feel for how easy it is to enter these equations and with constants, and to use the constant controller to explore them.
So I've dropped document 5 into the chat. Again, it's available in the Dropbox. It talks quite a bit about using slow plot and being able to use the pause options there, Doug. So hopefully people can have a go with that. We have got documents 6, 7, 8 that I think we're probably going to have to use at the beginning of next time, or you can have a homework task to work through those. The instructions are fairly straightforward to follow, and you can always drop us comments to @AutographMaths and @LaSalleEd. Hopefully it will give you some extra practice to work through some of those examples and answer some of the questions with how you actually access those documents. So I look forward to seeing those tweets that share that information. And I know that you all appreciate getting homework. I'm glad that you're finding the red tick for default scales useful. It is a lifesaver. It does bring you back to the center, so really useful. Doug, question, are there any prohibited letters for using as constants?
Yeah, we treat E as E, so E is E, and I is square root of -1. Those are the two that we don't allow as constants.
Yeah, hopefully that answers your question, Jen. The tasks from the first webinar session are available on the Salle website, and I can drop you the link to those tasks into the chat. But I know that there is a Dropbox link which will automatically download those documents for you. So if I can find the week 1 task, but there's the link to where the materials are hosted on the Salle site. Hopefully you are going to find the documents really useful. They do have the step-by-step how-to instructions and the tasks at the end. So hopefully you can work through those. Doug might be able to go over some of the missing parts from this session at the start of the next session, where we're going to look in a bit more detail. But hopefully you've got the afternoon where you can have a bit of a play.
I'll just quickly summarize what we've done today. We started off with the triangle properties and the straight lines, if you remember. That's 3D objects left over from the first session. Then we had a look at y equals mx+c and making sure that they really understood what the meaning of m and c is. Simultaneous equations, quadratic functions, moving them up and down and left and right, and completing the square. Drawing cubics, reciprocals, and exponential functions. And your homework are these tasks that we haven't got round to today, unfortunately, but the graphs of inverse functions, a very important, fairly new topic to GCSE, but used as a really lovely feature of creating attribute points, which we'll explain at the next session. Trig graphs, of course, very important that they understand how those work. And the concept of gradient without using the calculus word is another lovely way to show it using a skier up and down this graph. But there we are. That's the end of this session. I'll leave Rob to close it down.
Yeah, Chris, hopefully we'll be able to get a link to the YouTube recording added to the site as well. That can probably happen later today. I'm glad that you're enjoying using the constant controller. Hopefully you did find the session useful. The documents are usually available on the day of the session. It gives us a chance to run through the how-to and the task on the day. But we hopefully will have them to you about an hour before the course starts, so you've got a chance to download them and read through. Again, a very useful session. Hopefully, thanks to Doug, and hope you enjoy doing your homework tasks. And hopefully next week we'll be able to show you how we're using autograph within the Complete Maths platform. So fingers crossed for a bit of a autograph within Complete Maths demonstration. Thank you again for coming, and we look forward to seeing you next time when we're going to hopefully show you some more interesting autograph information and tasks.